So I want to talk about property testing. Quick note about me, I'm Hugo Sousa, I work at Codacy. And you can talk pretty much to me about anything related to functional programming or weird stuff you found about. Property testing, I've done the example in Java because it was more accessible to people because I work with Scala every day, and if I did it in Scala it wouldn't be as easy to read for everyone. Property testing comes from functional programming because property testing is basically using random data to run test cases on. So this comes from functional programming because I don't know if you're familiar with it, but in functional programming we try to push side effects into the end of the world, and then the rest of our program is all pure and does nothing wrong and has no side effects. And then when you run it, it does every computation that it needs to, and then it reaches the end of the world and it does all the side effects and everything to be a real program, or else it's not really useful. And since most of our program is pure, and those transformations are, and the program is basically transformations from data to data, you can test those transformations with random inputs and see if the properties you're expecting out still hold. So that is basically what property-based testing is, and that is why it was, I don't know, thought of as useful mostly for functional programming. So the original, I think, was done in Haskell, which is called Quick Check. In Scala you have Scala Check, which is basically a port from Quick Check. And in Java you have a slightly, I don't know if it's that slightly, but you have a weaker version in Valter. I don't know even how that's pronounced, but yeah, it's a functional programming library, and you can just include it, the test part in your test, and you have property-based testing available to you. As a quick example, let's say you have the function absolute on math, which is part of the standard library, and for all integers you can generate, you can see that the arbitrary which is imported from Valter has integers, so it is something that is able to generate arbitrary integers. And then you have the property which does the property testing, and this is all compatible with JUnit, which is what I use. It blends really well. You can get it up and running in a couple minutes. And so for all integers which come from this arbitrary, you can check that the math absolute equals the math absolute of the same number, but the other way around, inverted. And you can do check and assert that this property holds, and it will try a number of integers which you can configure, and it will try to fail this property that number of times with random data. So if I want to do something more sophisticated, I created a class which is a movie, which contains a title, a date, and it might have a rating or not yet. I've made it final with every property cannot be changed, and if you want to change the rating, you create a new movie. So functional programming style of changing data, you make a new movie with the same things, but with the new rating. So it's basically a copy with this other property. So that's basically a pure function because the original state is not changed, and then the final one has the rating you wanted. So you can do, you can test this property, you can do the sample size on top, and then since my movie had a title which is a string, date, time, and a rating, I need to be able to have generators for those data so I can build movies on top of that random data. So I don't know, you might find it boilerplate or so, but in order to generate options, I'm composing two arbitrary data generators, one which applies a random number and another one which generates an empty option. From string you have to provide a random character generator, so I just went from A to Z and apply it to the same sample size, and then the movie just from the random, because this takes the Java random as an input, the gen. And you basically create a movie based on the random generators you have before. And then you can create an arbitrary based on the gen you already have. It's how those interfaces add up. And then you can basically test the function I did before. So for all movies that I generate arbitrarily, if I copy a movie with no rating, then the rating needs to be empty. And so you check and assert that it holds up, and it will pass because the function has no bugs. But if you put a bug in there, you might catch it. So this is mostly used for pure functions, but at least in my company, we also use it for units and integration testing. So when integration, we use Scala check, and in Scala check, you don't have to provide as much stuff, but you can use it for these kind of tests. And when you look at your test data, it will have a lot of random stuff if the test failed. So it might catch cases which you would not because the random data generated a test case which you didn't cover on your normal unit test or integration test for that matter. So if you have a gen, you can just apply and pass a random to it, and then you get an instant which was randomly generated. So you can, if you need any specific properties, you can change them, or you can just do your normal asserts on it. And yeah, you can do all your tests with random stuff, mostly. Valter's property testing is really random based. On Scala check and quick tests, the randomness is not just random. It goes for specific cases where stuff is expected to fail. So if your input is a list, it will try a list with no elements and a really huge list, so it's way more sophisticated. So if anyone wants to get really good property testing, I can really write a wrapper in Java if someone wants to use it, because it's really quick. And one thing that I think makes a difference is if you go to this function would actually fail if you were using Scala check, because math.absolute returns the same number on integer.mean value, because it doesn't have a value that it can convert to. So this would fail on Scala check, and you have no way to make it fail on Valter. So yeah, that's it. It's a really simple concept that I think is useful for people.